Preventing exposure to crystalline silica dust. This guidance is to provide information on hazard identification and the control of risks of exposure to crystalline silica dust in construction. What is crystalline silica? Crystalline silica is a natural mineral found in construction materials such as concrete, bricks, tiles, mortar, and engineered stone. It includes substances such as quartz, cristobalite, tridymite, or tripoli. Here are some common materials and their typical crystalline silica content. Crystalline silica dust is generated when these substances are mechanically processed, for example, through construction activities such as cutting or grinding. These dust particles are small enough to be breathed deep into the lungs. Exposure to crystalline silica dust over a long period at low to moderate levels, or short periods at high levels, can lead to serious health conditions such as silicosis. Silicosis is an irreversible, incurable, and progressive lung disease that can lead to disability and death. Construction and demolition employees can be at risk of developing these diseases. Employers have duties to manage risks from crystalline silica dust under Part 4.1 and Part 4.5 of the Occupational Health and Safety Regulations. If you are unsure whether a product contains crystalline silica, check the safety data sheet or other information from the manufacturer or supplier.
This video is designed to help you identify and manage high-risk crystalline silica work. Crystalline silica can be found in many common building materials such as bricks, concrete, and tiles. Working with these materials can create hazardous dust. If this dust is inhaled, it can cause deadly lung and respiratory diseases like silicosis. Before you start work, the first step is to identify whether you'll be carrying out any of the following processes on materials that contain crystalline silica. Using a power tool or mechanical plant to cut, grind or polish, or any other activity that's likely to generate dust. Using a road header on an excavated face. Dust arising from manufacturing or handling. Screening or quarrying or tunnelling. Without considering controls in place, the next step is to determine if the process is likely to result in an airborne concentration of respirable crystalline silica that exceeds half the exposure standard or is a risk to the health of any person at the workplace. If either of these are likely, the process is classified as high-risk crystalline silica work, and you must prepare a crystalline silica hazard control statement or add this information into a safe work method statement. If you're unsure, you must complete a risk assessment and consider the following: the specific tasks or processes, the form, the proportion of crystalline silica contained in the material, previous atmospheric monitoring results, frequency and duration, information about incidents, illnesses or diseases associated with exposure. If you identify through the risk assessment that the activity is not high-risk crystalline silica work, you must keep a copy of this for the duration of the work. If you are still not sure, even after going through the risk assessment, you must treat it as high-risk crystalline silica work. This statement sets out the hazards and risks arising from the work, details the measures to control those risks, and how they will be implemented. Essentially, this document is the same as a safe work method statement. For example, under hazard, you could list concrete that may generate dust. For risk, you could list the risk of silicosis and lung cancer. Under control, you could describe the measures taken to control those risks, such as on-tool water suppression. Then under implementation, you would describe how the risk control measures are to be implemented, such as suppression being correctly installed and having adequate supply. When determining what controls to implement, start with the highest order of control as possible. Eliminate. Physically remove the hazard from your workplace. Substitution. Using material with less crystalline silica content. Isolation, isolating workers from exposure. Engineering controls, using on-tool water suppression or on-tool extraction attached to an industrial class M or H vacuum. Administrative controls, limiting exposure through task rotation. Personal protective equipment such as a P2 half-face respirator. Employers must consult with their workers and/or HSRs when identifying hazards and selecting risk controls. You must ensure high-risk crystalline silica work is performed in accordance with the hazard control statement. If it is not, work must not proceed. Employers are also required to provide safety training and instruction to any employees and information to any job applicants who may engage in high-risk crystalline silica work. This includes information about hazards, risks, and the measures to control those risks. To find out more, visit the WorkSafe website.
From July 1, 2024, the manufacture, supply, processing or installation of engineered stone benchtops, panels or slabs is banned in Victoria. The engineered stone ban applies to engineered stone benchtops, panels and slabs. Engineered stone products not in these forms are not banned. There are limited exceptions to the ban where work can be performed on engineered stone benchtops, panels and slabs. This includes the removal, repair or modification of installed engineered stone benchtop and panels. Disposal of installed or uninstalled engineered stone benchtops, panels and slabs. Research and analysis. And to sample and identify engineered stone. Specific controls are required when permitted engineered stonework involves an engineered stone process. An engineered stone process is also considered high-risk crystalline silica work, and you must comply with the high-risk crystalline silica work obligations. Safe Work Australia publishes exposure standards for airborne contaminants in the workplace. Under the OH&S regulations, employers must ensure employees are not exposed to respirable crystalline silica dust at the workplace at a level above the exposure standard. The exposure standard for crystalline silica dust is 0.05 milligrams as a time-weighted average airborne concentration over 8 hours. An 8-hour time-weighted average exposure standard is the maximum average airborne concentration of a particular substance permitted over an 8-hour working day for a 5-day working week. Where a workplace has working hours that exceed an 8-hour day or a 40-hour week, the time-weighted average needs to be adjusted to compensate for the greater exposure. The adjusted exposure standard for crystalline silica dust over a 10-hour day would be 0.035 milligrams. The workplace exposure standard for respirable crystalline silica is based on the airborne concentration within a person's breathing zone, outside of any respiratory protective equipment that may be in use. Employers are required to ensure employee exposure does not exceed this standard. WorkSafe Victoria recommends that employees are not exposed to levels above 0.02 milligrams per cubic metre as an 8-hour time-weighted average. This is a precautionary measure to prevent silicosis and to minimise the risk of lung cancer. What is a crystalline silica process? A crystalline silica process means one or more of the following processes carried out at a workplace. The use of a power tool or other form of mechanical plant to cut, grind, polish, or crush material containing crystalline silica or to carry out any other activity involving material containing crystalline silica that generates crystalline silica dust. The use of a road header on an excavated face if the material in the face contains crystalline silica. Or a process that exposes a person to crystalline silica dust arising from the manufacture or handling of material that contains crystalline silica. The mechanical screening of crushed material containing crystalline silica. A quarrying process involving material containing crystalline silica. A tunneling process involving material containing crystalline silica. Or a process determined by WorkSafe to be a crystalline silica process. High-risk crystalline silica work is an engineered stone process, or work performed in connection with a crystalline silica process that is reasonably likely to result in an airborne concentration of respirable crystalline silica that exceeds half the exposure standard for respirable crystalline silica, or a risk to the health of a person at the workplace. Identifying high-risk crystalline silica work. Before starting a crystalline silica process, an employer or self-employed person must identify whether the crystalline silica processes are high-risk crystalline silica work. This must be done by conducting a risk assessment or by choosing to treat that work as high-risk crystalline silica work without doing a risk assessment. If doing a risk assessment, Hallmarc or the subcontractor must consider the following factors: the specific tasks or processes required to be undertaken with material that contains crystalline silica, the form of crystalline silica to be used, for example, brick, concrete, or crushed rock, the proportion of crystalline silica contained in the material, the previous atmospheric monitoring results, the likely frequency and duration of exposure to crystalline silica dust, and any information about incidents, illnesses, or diseases associated with exposure to crystalline silica dust at the workplace.
Today, we're going to take you through the process of hazard identification for crystalline silica. Every day, employees work with materials containing crystalline silica in three main forms: solid form, such as a brick; respirable form, such as mortar; and liquid form, such as slurry. This can lead to exposure to respirable crystalline silica and can have serious consequences on employees' health. As part of a risk management process, it's important that employees identify all sources and even potential sources of respirable crystalline silica in their workplace. When identifying and assessing hazards and making decisions about risk control measures, employees must consult with their employees, including the health and safety representatives. So, what is the difference between a hazardous substance and a crystalline silica substance? Put simply, a hazardous substance is in respirable form, and a crystalline silica substance is not in respirable form. If you work with a hazardous substance, you can review a safety data sheet from the manufacturer or supplier and find crucial information, including the hazard identification for the substance, hazard and precautionary statements, the composition of the ingredients, the suggested exposure controls, the suggested engineering controls, and the suggested personal protective equipment. The labels on containers of hazardous substances can also provide basic information which is readily accessible by those employees who use it. The basic information includes the identity and proportion of the hazardous substance, pictograms, hazard and precautionary statements, and signal words. Or, if you work with a crystalline silica substance, you can review a product data sheet from the manufacturer or supplier and find information including the proportion of crystalline silica contained within the substance, the suggested exposure controls, the suggested engineering controls, and the suggested personal protective equipment. For further information or guidance on hazard identification, you can visit the WorkSafe website.
A crystalline silica hazard control statement is a document prepared for high-risk crystalline silica work carried out at a workplace. Similar to a safe work method statement for high-risk construction work, it sets out the hazards and risks arising from the work and details the measures to control those risks and how they will be implemented. If the high-risk crystalline silica work is being undertaken as part of high-risk construction work, the hazard control statement can be incorporated into a SWMS. An employer or a self-employed person must not perform high-risk crystalline silica work unless a crystalline silica hazard control statement is prepared for the work before the work begins, and the work is performed in line with that hazard control statement. If the work is not performed in line with the hazard control statement, the employer or self-employed person must stop that work immediately or as soon as it is safe to do so. Work must not resume until the hazard control statement is complied with or reviewed and, if necessary, revised in line with the OH&S regulations. An employer must review and revise the hazard control statement whenever the high-risk construction work changes. Whenever there is an indication that risk control measures are not adequately controlling the risk, and after any incident that occurs during the high-risk construction work changes. The hazard control statement must do the following. State the hazards and risks to health associated with the high-risk crystalline silica work. Clearly detail the measures selected to control those risks. Risks must be controlled in line with the hierarchy of controls in this guidance. Describe how the risk control measures will be put into effect. If an analysis is required of samples, contain the results of that analysis. And be set out and expressed in a way that is readily accessible and clear to the people who use it. A hazard control statement is not required for high-risk crystalline silica work where a SWIMS has been prepared, and the SWIMS addresses the matters required for a hazard control statement.
When controlling the risks of exposure to respirable crystalline silica, it's important to follow the hierarchy of control. If elimination and substitution are not possible, then engineering controls should be used. The two most common forms of engineering controls are on-tool dust suppression and on-tool dust extraction. Today we're talking about on-tool dust extraction systems. These remove dust at the source when working with crystalline silica materials. An on-tool dust extraction system is made up of a power tool, an on-tool attachment, and a hazardous dust class vacuum. Shadow vacuuming is not an engineering control or a form of on-tool dust extraction. The attachment is what connects the power tool to the vacuum. To work best, it needs to be as close as possible to the source of the dust. Attachments are tool and task specific. This means there are specific types of attachments designed for drilling, grinding, or cutting materials containing crystalline silica. Attachments that capture sawdust may not be effective at capturing respirable crystalline silica dust. It's important to ensure the on-tool attachment securely connects to the tool and the hose fitting. All connections should be fitted as the manufacturer recommends. Different hoses are available, and anti-static hoses are a good preventer build-up of static electricity. Hazardous dust class vacuums are fitted with a filtration system designed to extract and contain hazardous dust. These vacuums come in three classes: low, medium, and high. When working with crystalline silica, the vacuum needs to be at least an M or an H class. To easily tell if a vacuum is one of these classes, look for this sticker on the side. If a vacuum isn't classed as an M or an H class, it's not suitable, even if it's marked as having a HEPA filter. It's important to choose the right vacuum for the job. Some things to consider are the tasks it will be used for, its compatibility with power tools and attachments, whether it's battery powered or corded, the weight and capacity, and if it needs to be a wet and dry vac. As you plan for your job, if you have any questions about the equipment, speak to the manufacturer. Waste management can be a source of re-exposure. So disposable bags inside the vacuum can be used to capture dust for easier and safer removal. You should always replace or clean the filters as the manufacturer recommends, avoid using compressed air, and dispose of offcuts appropriately. For more information, please visit the WorkSafe website.
Employers must control the risks associated with exposure to crystalline silica by applying the hierarchy of control in Part 4.1 of the OH&S regulations. An employer must, so far as is reasonably practicable, eliminate the risks associated with exposure to crystalline silica dust in their workplace, for example, by using non-silica containing products. If it is not reasonably practicable to eliminate a risk associated with crystalline silica, the employer must reduce the risk so far as is reasonably practicable by substitution. For example, instead of using cement-based grouts that can contain silica-rich sand which can release RCS during mixing and sanding, use epoxy-based or pre-mixed polymer grouts which can have a much lower silica content. Isolation, for example using automated wet machines. Engineering controls, for example using on-tool water suppression. Or a combination of any of these risk control measures. If the risks from exposure still remain after the listed risk control measures have been implemented, administrative controls must be used to reduce the risk so far as is reasonably practicable. Administrative controls include, for example, rotation during shifts between high and low exposure tasks. If, after implementation of administrative controls, a risk to health from exposure to crystalline silica dust remains, reduce that risk, so far as is reasonably practicable, by providing appropriate personal protective equipment to employees at risk, for example respiratory protective equipment such as a half-face negative respirator or powered air purifying respirator. If a risk remains, an employer must provide appropriate personal protective equipment, such as respiratory protective equipment. It is most likely that more than one control will be needed to control the risk adequately. Employers must consult with their employees, including independent contractors, and any health and safety representatives, so far as is reasonably practicable, when identifying hazards and risks associated with crystalline silica exposure. Employers must also consult when deciding on how to control risks.
Exposure to respirable crystalline silica can have serious consequences on employees' health. This is why it's so important for employers to provide the relevant information, instruction, and training to their employees. If employees are likely to be exposed to risks while performing high-risk crystalline silica work, employers must provide information, instruction, and training across key areas. Information, instruction, and training about health risks should cover what illnesses and diseases are associated with overexposure, such as silicosis, the exposure route, and the exposure standard. So, how do you implement the risk controls? Information, instruction, and training about risk controls should cover how to use them and why they are needed. For example, an employee may need to use on-tool dust extraction while drilling into concrete. The information, instruction, and training should explain how to use this system and how it will reduce exposure to crystalline silica. This includes the setup, use, and maintenance of the system, like how and when to clean the filters and replace bags. Let's talk for a moment about implementing the risk controls. Information, instruction, and training about implementing those risk controls should cover how the risk controls are going to be integrated into the workplace, and who to ask if there are any questions. It should be done following consultation with the relevant employees and the health and safety representatives. For further information and guidance, visit the WorkSafe website.
Information, instruction, and training needs to be provided to employees who are likely to be exposed to risks associated with undertaking high-risk crystalline silica work, including the health risks associated with exposure to crystalline silica dust, the need for any risk control measures required by the OH&S regulations, the proper use of any risk control measures required by the OH&S regulations, and how the risk control measures are to be implemented. Employers must provide supervision to employees where supervision is necessary to enable those employees to undertake their work safely. This is particularly important with employees who are more vulnerable, such as new, inexperienced, or young employees. This duty also extends to independent contractors, including any employees of the independent contractor engaged by the employer in relation to matters over which the employer has control.
This is the process for atmospheric monitoring and when it's required for respirable crystalline silica. Atmospheric monitoring is commonly referred to as air monitoring. Respirable crystalline silica is a hazardous substance. The health impacts of exposure include silicosis, lung cancer, and autoimmune diseases such as scleroderma. Employers must ensure that their workers are not exposed to a concentration of a hazardous substance, such as respirable crystalline silica, above the relevant exposure standard. You can find exposure standards on the Safe Work Australia website. Exposure standards are generally set at the lowest airborne concentration that's unlikely to cause harm. Air monitoring enables us to understand what level of respirable crystalline silica a worker is potentially breathing in. In order to compare a person's exposures against the exposure standard, measurements must be made in a person's breathing zone. Air monitoring involves an employee wearing a pump with an air sampling device attached and positioned in the worker's breathing zone. The sampling device has a small filter in it that captures the respirable dust. Monitoring should occur over the full shift, or at least the majority of it, so as to get a representative sample. The filter is then analysed by a lab. The results will then be interpreted to understand if a worker is likely to be exposed to a level of respirable crystalline silica above the exposure standard. Both the air monitoring and the interpretation of results needs to be done by a person who's adequately qualified and experienced, such as an occupational hygienist. Air monitoring is required if an employer is unsure if their workers are exposed to a level above the exposure standard. Air monitoring results need to be provided in a report that discusses when the monitoring took place and what work was observed to be happening on the day. The report should detail the systems of work, identify the sources of exposure, help determine if the controls in place are effective, and provide site-specific recommendations. Results must be provided to all workers who have been or are likely to be exposed to respirable crystalline silica. Routine air monitoring could form part of an employer's systems of work to confirm if controls are being maintained. In some situations, static monitoring may be conducted to help with evaluating the effectiveness of some controls. This is where the pump and the air sampling device are in a fixed location and not on a worker. The results from static monitoring can't be used to determine a worker's personal exposure. Real-time dust monitoring may also be used to help with evaluating the effectiveness of some controls. But these results also can't be used to understand a worker's personal exposure. A good place to find a suitably qualified person to undertake air monitoring is through the Australian Institute of Occupational Hygienists. For further information and guidance on air monitoring, visit the WorkSafe website.
Atmospheric monitoring, also known as air monitoring, for crystalline silica involves sampling the air for respirable crystalline silica within the employee's breathing zone. By law, employers must carry out atmospheric monitoring, also known as air monitoring, if they are not sure if their employees are exposed to levels of silica dust that are above the exposure standard. The 8-hour time weighted average workplace exposure standard for respirable crystalline silica is 0.05 milligrams per cubic meter. This means workers must not be exposed to levels of respirable crystalline silica greater than 0.05 milligrams per cubic meter over an 8-hour working day for a 5-day working week. Or they can't work out if there's a risk to employee health without air monitoring. Employers should carry out atmospheric monitoring when there are changes to work practices, the materials being used, or the work environment. If a health monitoring report for an employee indicates a negative change in health status which may be related to silica exposure. If a health and safety rep requests a review of control measures because there is uncertainty based on reasonable grounds as to whether the exposure standard is or may be exceeded. Or if there are changes to the workplace exposure standard, and previous atmospheric monitoring results have indicated levels above the new standard. The interpretation of these results, including comparison with the exposure standard, should be carried out by a competent person to determine employee exposure to crystalline silica dust. An occupational hygienist is an example of a competent person. Results of air monitoring must be shared as soon as reasonably possible with employees who have been or may have been exposed. Employers must ensure health monitoring is carried out for an employee if exposure to crystalline silica is reasonably likely to have an adverse effect on the employee's health. Health monitoring must be done under the supervision of a registered medical practitioner. Health monitoring should be carried out by a specialist occupational and environmental physician or respiratory physician with expertise in respiratory and silica exposure health monitoring.
Let's talk about when health monitoring is required and what the process looks like. Employers are required to provide health monitoring if an employee's exposure to respirable crystalline silica is reasonably likely to have adverse effects on their health. This may include where employees are regularly inhaling levels of crystalline silica likely to be above the exposure standard, even if employees are using lower order controls such as respiratory protective equipment to control their exposure. Silica-related illnesses can be caused by short exposures at high concentrations or by the cumulative effects of lower level of exposures over an extended period of time. Health monitoring is important as it provides information that enables action to be taken to protect any affected worker's health. If it's required, employers must organise and pay for health monitoring. For labour hire workers, the host employer and the labour hire employer must consult with each other to work out who will organise and pay for health monitoring. Health monitoring must be conducted under a medical practitioner's supervision. It can involve a medical questionnaire, a spirometry test, a chest X-ray, or a CT scan, depending on the type and level of exposure. The medical practitioner will provide the employer with an interpretation of the results and any findings of adverse health effects. The results must be given to the worker as soon as possible. WorkSafe has a template employers can use. If the report identifies any adverse health effects, the employer must review the controls in place to make sure that they are effective, and if any further controls may be required. When reviewing controls, health and safety representatives or employees need to be consulted. If the report recommends that an employee should not be exposed to respirable crystalline silica for a period of time, then the employer should follow those recommendations. For example, the employee may have to be assigned to alternative work or another location where exposure to the substance will not occur. This must be done after consulting with the employee and the medical practitioner. The report must also be sent to WorkSafe Victoria. For more information on health monitoring, visit the WorkSafe website.
Where health monitoring is required, it must be completed in line with the recommendations of the registered medical practitioner. This may include regular testing periods while employees are on the job, before newly hired employees start work with a new employer, and when employees finish working for that employer. Respiratory protective equipment must be worn where a risk still remains after higher order controls have been implemented, including in all situations when health monitoring is required.
When controlling risks associated with respirable crystalline silica, it's important to follow the hierarchy of control. If elimination, substitution, or isolation aren't possible, engineering controls should be used. The two most common forms of engineering controls are on-tool dust extraction and on-tool dust suppression. This video will talk about on-tool dust suppression. An on-tool dust suppression system uses a continuous supply of water to control dust at the source. These systems are made up of a power tool or machine, a water source, a water outlet, often in conjunction with a shroud or a guard, and sometimes a vacuum. On-tool dust suppression can be used with a range of tools and machines, including saws, grinders, corers, jackhammers, and excavators. If you choose to use on-tool dust suppression, it's important to plan ahead so you have access to clean water. This can be supplied by the mains or by a tank. If you're recycling or recirculating water, it needs to be adequately treated or replaced frequently. If water containing crystalline silica is used, this may result in re-exposure. The water supply needs to be directed at the point of contact, and the flow rate needs to be high enough to suppress the dust. This is usually around half a litre a minute. Any overspray needs to be pointed away from you or anyone else. On-tool dust suppression systems will create a slurry that contains crystalline silica. This is why it's so important to consider how and when slurry will be collected, cleaned, and disposed of, as re-exposure can occur if it's left out to dry. Collection and cleaning methods can include cleaning the slurry with a wet-dry vacuum, shoveling the slurry into a bag while it's still wet, or collecting the slurry at the source. Offcuts also need to be collected and disposed of appropriately to eliminate any further dust from being created. Lastly, if you plan to use an electrical tool, machine, or extension cord, always ensure they're safe to use around water. For further information, please visit the WorkSafe website.
Respiratory protective equipment, or respirators, can reduce a person's exposure to respirable crystalline silica, but it's important to know where respirators fit in the hierarchy of control. Respirators are at the bottom of the hierarchy of control, as they have the lowest level of protection and reliability. This means employers must seek to use a higher order of control first, and then look at using other options. Respirators are commonly required in two types of situations: to further reduce exposure when a higher level of control isn't enough, or if a respirator is the only option. But often a combination of risk controls may need to be used. Respirators work by either filtering contaminated air or supplying clean air, so that a person's exposure to the contaminant is reduced. Always choose a respirator and filter that is suitable for the task. There are many different types of respirators available for working with crystalline silica, including disposable respirators, half-face and full-face reusable respirators, and powered air purifying respirators, also known as PAPRs. All of these need to be used with a particulate filter when working with crystalline silica. Tight-fitting respirators need a facial seal to work properly. Facial hair of any length can break the seal and make respirators ineffective. However, loose-fitting respirators with powered or supplied air can be used by people with facial hair. This is because loose-fitting respirators create a positive pressure, so they don't rely on a facial seal to be effective. For tight-fitting respirators, there's no one-size-fits-all due to the differences in everyone's facial features. This is why fit testing is a good way to confirm which respirator is suitable for each person. A fit check, on the other hand, should be done each time before using a tight-fitting respirator. So what's the difference between a fit test and a fit check? A fit test is done by a competent person to verify that the make, model, and size of the respirator is right for the user. A fit check is a self-check the user will do each time they use the respirator. Employees must be provided with information, instruction, or training to enable them to use and maintain a respirator safely. Key aspects to cover off are how to wear the respirator and conduct a fit check, whether facial hair is permitted with the type of respirator, when and how to place the filter cartridges, if relevant, and how to maintain and store the respirator when it's not in use. For further information and guidance, visit the WorkSafe website.
Workplaces like demolition, civil, infrastructure, and extractive industries can create respirable crystalline silica through day-to-day activities. Silica dust can pose a serious risk to health. It's important to control this risk using the hierarchy of controls. When it comes to which controls to implement, always start with the highest level. Think about whether it's possible to eliminate the risk and physically remove the hazard from your workplace. This video will cover some options for risk controls for large tasks or machinery, when removal isn't an option. Dust suppression systems, which use a mist of water, can be on-tool, portable, fixed, or handheld. These include fogging cannons, fixed misters, and handheld misting hoses. All of these produce ultrafine droplets of water to capture and suppress airborne dust. Additives like surfactants can be added to water to make dust suppression even more effective. Fogging cannons or foggers are often portable and work best when they are placed upwind of that work area. Fixed misting systems work best when they surround a work area. The ultrafine mist acts like a curtain of water, preventing the spread of airborne dust. Where fixed or portable dust suppression systems aren't suitable, misting nozzles can also be attached to handheld hoses. Machines with enclosed filtered cabins are a great way to reduce exposure to silica dust. They do this by preventing dust from getting inside the cabin. Silica dust can also make its way into the cabin from your clothing or your shoes. Some machines are also fitted with a filter circulation system to remove dust from inside the cabin. When the machine is not in use, close all windows and doors to keep the dust from settling inside. Cabins need to be cleaned regularly, and filters need to be inspected and replaced to make sure controls remain effective. Large ventilation systems like air scrubbers can be used to remove dust from the air. These systems work best when paired with other controls. Air scrubbers are great for enclosed or partially enclosed work areas, where silica dust can build up. When setting up and maintaining these systems, consider the airflows and direction. Dust curtains can be used to direct airflow towards an air scrubber, or to contain dust within a work area. To be effective, dust curtains should be creating a seal. Dust curtains need to be paired with other controls like dust extraction or dust suppression system. To keep dust from becoming airborne from areas like stockpiles, haul roads or conveyors, polymer sprayers can be used to form a film over that material. If you'd like to learn more about other crystalline silica controls, please visit the WorkSafe website and view other videos in this series.
Thank you for your time.